All right, so we were looking at the table with our Hep C users, and I'm just going to add a slide here because what we want to calculate is the NPV for the general population. And then we're going to calculate the NPV for the injection drug users. And we know that just like the PPV, these are going to be different. Basically, with the PPV, it's telling us you have a better chance of a positive test, meaning that someone has the disease, if you are dealing with a population with a higher prevalence. And let's take a look at what happens to our numbers here with our NPV. So again, have your numbers handy, or your formulas handy, and your table handy. When we look at the NPV, the negative predictive value, that's going to take a look at our true negatives out of all of our negatives. So look at your general population first. You're going to have, in this case, one true negative, one person that, or excuse me, sorry, reading my table wrong there. We're going to have 441 true negatives. And think about how many total negatives. In this case, you had one person who didn't have Hep C tested negative, meaning total, there were 442 people who got a negative test result. So when we calculate our NPV, we're going to do 441 true negatives out of 442. So I want you to focus on the fraction for a second. Make sure we got that part right. And then I didn't drop it into Desmos yet, but if we just do 441 out of 442, notice that's 0.9977, super high, right? So what that tells us is that this test has a really high negative predictive value for the general public. Meaning, if you're a general public or just a general person and not identified as a drug user, and you get a negative test, you're probably negative. You probably don't have the disease. Let's take a look at the injection drug users. So going back to our table, take a look at your negative row. For the true negatives, the true negatives are those who don't have Hep C and get a negative test. There's 194 true negatives. And then take a look at those 28. Those 28s were negatives, but they should have been positives because they had Hep C and they tested negative. So think about that's 28 false negatives in that case. So the true negatives is 194, and the total negatives will be our sum. So let's take a look at our ratio in this case. So in this case, we would have 194 on the top. And then for our total, just so you can see where I'm getting this number, which is a little tougher than the 442. 194, that's our 28. All right, so let's drop that into Desmos. All right, so let's go 4 decimal places with this one. In Desmos, it's telling me 0.8739. So let's analyze that number. This is saying that if we know we're looking at a group of injection drug users and we get a negative, that negative is only 88% chance of actually being negative. In other words, that's a lower percent than we were seeing for the general population. But when we were looking at our PPVs, those actually flip-flopped a little bit. So in general, it would be wonderful to have a really high PPV. In other words, when you get a positive, for it to mean the person has the disease, and a high NPV when you get a negative, for it to mean that you don't have the disease and rule it out. when you have a low PPV or a low NPV, you might want to think about retesting. For example, if you were in the population of injection drug users and you got a negative test, but you know that's only 88% chance of being correct, well, you don't want to be in that 12% chance where it's wrong, right? You might want to say, hey, well, I don't want to be a false negative. Maybe I should retest, okay? Or maybe there's an alternative test that I need to take. So again, some of the PPV and NPV dictates what you do with your results. All right, so let's stop there for a second and take any questions before we go on. All right, so let's go on. We're going to do another example. No more new terms, just kind of a new configuration of us setting up. We're going to set up a table that kind of looks like this versus them giving it to us. So I'm going to put this slideshow back into this mode. Can you guys see? Actually, stop that slideshow and reshare that. Hopefully that worked. Okay, so let's go ahead. It started me from the beginning here. Let me go ahead and go back to where we were. So we actually finished the NPVs, and here were the PPVs. Let's take a look at a new setup. So suppose that a certain drug test is 95% accurate, meaning that if a person is a user, the result is positive 95% of the time. And if he isn't a user, it's negative 95% of the time. Assume that 5% of all people are drug users for this particular drug. So I want you to read that back to yourself, and then we're going to break this one down. Notice that this one uses the term 95% accurate. When they say 95% accurate, they go on to tell you it means a positive, if the person is a user, it's positive 95% of the time. The test is positive 95% of the time. And if a person isn't a user, the test is negative 95% of the time. What they're actually telling you with this 95% accuracy is a 95% sensitivity. That person is a user, the result is positive 95% of the time. And specificity, if a person isn't a user, you're negative 95% of the time. That's telling you the sensitivity and specificity. Okay, so sometimes they'll use that verbiage rather than using the sensitivity and specificity. Then the 5%. This 5%, I don't love this one because it's not 5% related to these 95s. It's just saying 5% of the population are drug users. We're going to go back and compare this to 20%. Like, what if it wasn't 5%, but 20%? A higher prevalence. So that 5% is the prevalence. Okay? The prevalence level is going to impact our results. So if they ask us the sensitivity, 95%. Specificity, 95%. Then what they want us to do, and this is the trickier part, is complete a table that simulates what we just did. Now, in the one we did with the injection drug users, we looked at general population and injection drug users, Hep C for both. We are just looking at one population. We're not doing a double table. But in this case, we're also doing total columns. So what I'm going to do is show you guys how to break this down and fill in your boxes. We're going to do it 2 times, one with this 5% prevalence, and then we're going to go back and do it with the 20% prevalence. And what we're going to do with the table afterwards, the next questions are going to be PPV and NPV. That's kind of what we're going after. So I'm going to stop my share. And instead of showing you the completed table, what I'm going to do, let's go to the iPad here, is go ahead and show you how to do the table as you go. Sorry guys, my iPad is being a little slow here, getting what I need. All right, so that should share my screen. And what you want to focus on first of all is we're assuming the population is 10,000. Why 10,000? Well, there's nothing necessarily magical about the 10,000 number other than it gives us nice whole numbers. We could have used 100,000. Sometimes 1,000 is too small to give us nice whole numbers across the table. And then we don't want to go so big as like 10 million because then our numbers tend to get too large and just make our table cumbersome. So 10,000 is just a popular choice. And what it's saying is if you scale this up to 20,000, 30,000, 100,000, a million, your ratios are going to be the same. We're just doing a representative table for a fixed population. So first thing you should do is focus on your prevalence and your total. Now, for this one, your grand total, this 1,000, excuse me, your 10,000. Sorry, guys, I can't talk there. Your 10,000 is your grand total that I always do first. Now, the next thing to break it up into is using that 5% to talk about your prevalence. Only 5% of that 10,000 are drug users. So write that out in terms of the calculation. Okay, so a good time to have a calculator handy. Or you could also think about, on the flip side, if you did, let's see, I think I did both here. This one. Or you could also do 95% who aren't. So if you did on this one, 5% of 10,000, we should get 25 people. Okay, so we just want to drop it into Desmos, check that really quickly. I have you guys just kind of check these numbers as we go, because one thing about this table is if we make a mistake one place, we're going to have, like, everything else is going to be wrong. You'll see that we just kind of base this on an iterative process. Okay, so, oh, sorry guys, I said 25, and I was looking at the wrong thing in my table. So good thing I'm double checking here. If you do 5% of 10,000, sorry guys, too many screens open, you should get 500. So let's go back here and big eraser. Sorry about that. So here, 5% of our 10,000 is 500. So think about, that's how many people are drug users out of our 10,000. Now, if you think about how many are left over, you still only have 10,000 in your population. So that leaves you 9,500 that are not users. So this is where you kind of see we need to double check, because if we're getting, like if I'm looking at my table before and I write down 25, which is actually the box above, we're going to see where we get that from, then that messes up the subtractions I'm going to need for that one. Okay, so use your prevalence to figure out how many people are drug users and subtraction for not a user. Then you're going to use your 95%. So 95% sensitivity and 95% specificity means that we're going to take a look at those 500 people. So if those people are drug users and the sensitivity is 95%, that means that 95% of those 500 should get a positive test result. Okay, so let's run that. So I want you to check it in Desmos. I'm going to do 0.95 times 500. Make sure I'm putting it in the right place here. So that's 475. And that's how many we expect to test positive. Then if we only had 500 total, means 25 of them who are drug users are going to test negative. Now, a second ago when I was looking at that 25, I was just looking at the wrong place on my table where I wrote it out earlier, not looking right. But we're going to repeat this idea in the next column. So for the not a user, that's using the 95% specificity. You have to be careful where we put everything. If you're not a user, then 95% of those should get a negative, meaning not a user, a negative is the correct thing to get. So 95% of our 9,500 should get negatives. So we're going to drop that into Desmos. And that number is 9,025. So that's the negatives. Be careful. We're actually kind of filling this in, not linearly in terms of our table. So you fill in the not a user and negative first. And then let's see, that's going to give us 475 to get to our 9,500 who tested positive, but were not a user. Now, let's think about that. That's only 5% who test positive that aren't a user. But think about if that's you, right? If you are not a drug user and you're undergoing a drug screening and you test positive, right? This is, you test positive, but you're not a user, right? That's 5% of people, right? A small amount, but 5% you're accusing someone, or you might accuse them of something that isn't true if you're doing like an employment drug testing. So we want to make sure we interpret those numbers. We would like for those sensitivity and specificities to even be higher than 95%. So let's think about our other two columns. We're going to sum across our rows. So in other words, get your total number of positives, 475 plus 475 gives us 950, and get your total negatives, 25 and 9,025 gives you 9,050. And then as a double check, one last double check, sum down your column. If you sum 950 and 9,050, it also sums to 10,000. So you should have your column totals and your row totals both equal that grand total. So that was a lot of work. Before we go on, questions here. So what we want to do is calculate the sensitivity, or excuse me, calculate the PPV and NPV. We already have sensitivity and specificity. So let's do our PPV. These are back in the PowerPoint, but let's go ahead and do it together. I want you to take a minute and look at the table that you just created. See if you can calculate, you can just do the fraction part, it's fine for right now, the PPV and NPV. What would you divide? And then we'll take a look. So let's take a look at it together. I always have to write my definitions back out. PPV is true positives over all positives. NPV, true negatives over all negatives. Then let's take a look back at our positives. This is looking at just a single row. Whereas, just to help you out, the sensitivity and specificity are looking at the columns individually. NPV and PPV are looking at your rows individually. So for this one, we had 950 total positives. And the ones that were drug users and tested positive were the correct positives. So in other words, we had 475 correct positives, 475 incorrect positives. So fill this in, true positives out of all positives. the 0.5, or turn it into percentage, about 0.50, 50%. What that means is, I mean, that's a pretty low PPV. What that is telling us that if a person were to test positive, it would only be right 50% of the time. In other words, if you don't already know if they're a drug user or not, a positive test is only accurate 50% of the time to have someone who's truly a drug user with this prevalence. Then take a look at your NPV. Your NPV, your true negatives, let's take a look back, over all of your negatives. I'm just gonna look at our negative row. We have 9,050 negatives. And if we looked at those, the true negatives, we have 9,025. So we can already tell, looking at those ratios, this is going to be a much, much higher value. So I think I have this one recorded to 3 decimal places, 0.997 or 99.7% NPV. So this is a pretty high NPV, meaning if someone gets a negative test, we can be pretty sure that they actually are not a drug user. So this kind of thing indicates what we should do. In other words, are we happy with this or not? In other words, if you got a negative test, this is saying, hey, we probably don't want to retest you. 99.7% chance that you're not a drug user. But on the flip side, if you are a person who tested positive, I'm not happy that only 50% of those positives really mean they're a drug user. I'd probably want additional confirmation. To me, that wouldn't be enough for a conviction or to make an accusation. So let's go ahead. I'll stop this share. Before I do that, any questions? Our slides kind of pick up here. With just phrasing what we did. You'll see that in the slides, they went ahead and filled the table in. And then this is what we just used, or what we just did. What's the PPV? Okay, that was our 50%. And then they kind of phrased the follow-up question here. If you found out a student was expelled because she tested positive for a drug with this test, would you feel that that action is justified? This kind of ties in with what we were saying before. Hopefully, most of you would say no. The test is only right half of the time when it reads positive. The other half of the time when it reads positive, it could have been a false positive because of the way our table worked out. In other words, it's not good for making an accusation. So when we looked at the NPV, this is what we did with our other one, we found an NPV of 99.7%. So think about a question you could do here. If you found out the student who had been accused of drugs was exonerated because she tested for drug use using the test, because she tested, I should say tested negative for drug use with this test, would you feel that the action was justified? In other words, if she got a negative test, do you feel like that's enough evidence? Hopefully, you would say yes, because 99.7% of the time when you get a negative, it's truly negative, or the person truly was not a drug user. So the last thing we're going to do today is go back and revisit the case where our prevalence changes. So suppose we have a test that is 95% accurate. Same accuracy, so this means 95% sensitivity, 95% specificity. The only thing that's different for us is we're going to look at a 20% prevalence instead of a 5% prevalence. So what I want you to do, realize we're almost out of time here, guys. If you have a few minutes to stick around, let's go ahead and fill this table in, and then we'll go ahead and calculate the PPV and NPV. If you have to go ahead and pop off, that's okay. It won't be very long. So I want you to, I'm going to go ahead and stop my share and share my tablet, but I want you to go ahead and think about how you would fill this table in. Okay, so let's go through it together. Here, if we look at our 20%, we're going to combine our 20% and still assume a 10,000 population to start filling in that bottom row. So keep in mind your grand total is 10,000. And then this time, 20% are drug users. So if we do 20% of 10,000, that's going to give me 2,000. So if 2,000 are drug users, then 8,000 are not. Then what we're going to do is use our 95% to fill in our columns. So think about if you had a drug user, 95% of your drug users should get a positive test. So 95% of that 2,000 is actually 1,900. Looking at what I did previously there. So if you have 1,900 drug users out of that group and 2,000 people, that leaves 100. Then you're going to repeat a similar thing for your not a user column. Think about for testing negative. 8,000 people were not users. 95 of those people should get a negative result. So go ahead and do our 95% times our 8,000. And for that one, 95% of our 8,000 is going to be 7,600. And that number is going to go in our test negative. And then we have 400 that we expect to test positive. Excuse me, guys. Okay, so let's go ahead and add across 7,700 here and 2,300 on the other. So let's just go back to the previous table and just make some general comparisons. Notice on this one, for your drug user, you have more who test positive, few who test negative. More who test negative in the not a user column and fewer who test positive. That sort of same pattern is reflected here. So when we calculate our PPV and NPV, we're going to use this table and we're going to get different values. So let's go ahead and do that quickly, and that's where we'll end here. So let's think about our PPV first. PPV is true positives over all positives. So think about for this one, we had 2,300 positives. And the true positives were the drug users. Those were the 1,900 out of 2,300. Okay, so I'm just going to pop over to Desmos and do that division for us. And that's going to give me 0.8261 approximately, or we could say about 83%. And then if we're looking at the NPV, let's do that up top here. This is going to be our true negatives over all of our negatives. So if we look at our negatives, we had 7,700 negatives, and our true negatives were those who were not users. That's 7,600. So we'll drop that into Decimals, and that one comes out to be 0.9870, or about, to 2 decimal places, 99% for our NPV. So notice how different our values can be. Notice in our previous one, our NPV was still pretty high, but our PPV wasn't. When you have a higher prevalence, your PPV tends to go up. So this is actually one of the reasons why people are pre-screened. For example, if you go into your doctor's office complaining of your leg hurting, they're not going to give you a strep throat test. They're going to give you a strep throat test if you have symptoms that are presenting, because they have a reason to think that you have the disease. Because the general population who doesn't have those symptoms might have a lower PPV. Like you might get wrong, either correct results less of the time or incorrect results more of the time when you're not matching those up. So some funny things can happen. Notice in that 5% drug use case, we had a high sensitivity and high specificity, but that doesn't necessarily mean a high PPV. So you just want to be careful and run the numbers through these tables. The biggest thing on this section is, what in the world are they asking? Like, are we talking sensitivity, specificity, PPV, NPV, and then thinking about what that would mean in the context. So to give you guys practice with this, let me just show you on Blackboard for the benefit of those who are watching. I just opened up on our break the lab for us, and this is the last lab of this unit. Switch us over here. So you already hopefully completed most of the STD risk lab. If you haven't, try to get that in. Today was, at the end of the day, was hopefully all of those will be submitted. I'll go through and start giving feedback. But this is the medical testing and conditional probability. Really, all the questions on this lab are the medical testing. So read through these carefully. They're going to give you lots of different numbers. Use your notes, read through them carefully. Let me know if you have questions. I do have office hours after this. So you're welcome to sit there and ask some questions if you have any. But as far as this lab, this is our last lab for Unit 3. So continue to work on it. We're actually going to build on to some of these ideas on Thursday and switch gears a little bit. So we're not going to work, like we're not going to substitute, said Thursday guys, sorry, Wednesday. We're not going to substitute class time for this. And I actually do have one change for Wednesday. I found out after I had announced a Zoom meeting for Wednesday that I have another meeting that unfortunately I need to go to, kind of competing things going on. So what I'm going to do for Wednesday's class is back up a little bit and give you guys a pre-recorded video, and then I'm going to pop on at 1 o'clock if you guys have questions, so that I can give you guys some time live, but also those videos to get you going. I think in terms of the difficulty level, this medical testing, because all of our terms are new, is probably some of our hardest parts. And I feel like what we're going to do Wednesday is a little bit more familiar in terms of expected value in our statistics. So hopefully that reassures you. We're not building onto this part. So any questions here? I would also recommend, before you jump into the medical testing and conditional probability lab, try some of the WebAssigns. I went ahead and opened that WebAssign up. It's the WebAssign for 5.2. If you feel like you need some practice and you want to check to see if you're getting it right, do those. They're very, very similar to the lab questions. That way you feel confident about it when you get to the lab. All right, guys, thank you for sticking with me and participating. I will see you guys hopefully at that second part of class on Wednesday. Have a good day.